In this video, we're going to cover the measures of the spread of the data. The most common measure of variation or spread is called the standard deviation. It's a number that measures how far the data values are from the mean. The standard deviation provides a measure of the overall variation in our data set. It's always positive or zero, and when it is small, then that means that the data are concentrated close to the mean. And when you have a standard deviation that is larger, then the data are spread out from the mean. So suppose that we are studying the amount of time customers wait in line at the checkout at supermarket A and supermarket B. So here's supermarket A, here's supermarket B. The average wait time at both supermarkets, or the mean, is 5 minutes. At supermarket A, the standard deviation for the wait time is 2 minutes. And at supermarket B, the standard deviation for the wait time is 4 minutes. Because supermarket B has a higher standard deviation, we know that there is more variation in the wait times at supermarket B. Overall, wait times at supermarket B are more spread out from the average, whereas wait times for supermarket A are more concentrated near the average. And you can see that represented here in the two different number lines. Notice when we have the standard deviation of 2, which is smaller, that the data points are closer to the mean. And when we have the standard deviation of 4, then those data points are spread out further from the mean. We can also use the standard deviation to determine whether a data value is considered close to or far from the mean. Let's take a look at an example. Suppose that Rosa and Ben both shop at supermarket A. Rosa waits at the checkout counter for 7 minutes, and Ben waits for 1 minute. At supermarket A, the mean waiting time is 5 minutes, and the standard deviation is 2 minutes. The standard deviation can be used to determine whether a data value is close to or far from the mean. So let's take a look at Ben first. So Ben's wait time is 1 minute, which is 4 minutes less than the average of 5 minutes. Ben's wait time of 1 minute is 2 standard deviations below the average of 5 minutes. And we find this because we know the standard deviation is 2 minutes, so that's 2 minutes. So that is 1 standard deviation. And there's 2 more minutes, which makes 2 standard deviations. Now let's take a look at Rosa. So her wait time of 7 minutes is just 2 minutes longer than the average. So her wait time of 7 minutes is 1 standard deviation above the average of 5 minutes. It's because it is 1 standard deviation equals 2 minutes, and her wait time was 2 minutes more than the average of 5 minutes. So in general, we will use this equation where the value equals the mean plus the number of standard deviations times the standard deviation. Remember that the number of standard deviations doesn't need to be an integer. So you could be asked for 1.5 times. So don't be confused if you notice that the number of standard deviations is not an integer. Now let's take a look at these two parts here. So remember that Ben waited 1 minute in line, and we said on the previous slide that that's 2 standard deviations less than the mean, and we use the number line to do that. Here we can plug it into this equation up here and just verify that 1 minute equals 5, that's the mean, plus -2, so that's the 2 standard deviations less than the mean, times 2, which is the standard deviation. Then we can do the same thing for Rosa, who waited 7 minutes, and we can verify that the number of standard deviations is 1 by, again, plugging it in this equation and verifying that the mean plus the number of standard deviations times the standard deviation is in fact 7. So just recall here what this is this is noting the different way that we express a sample versus a population. So let's talk about how we determine if a data value is close or far from the mean. Well, if you have a data value that's 2 standard deviations from the mean or the average, that's what we consider to be borderline. And many statisticians would consider that to be far from the average. Considering data to be far from the mean if it is more than 2 standard deviations is more of what we call a rule of thumb than a rigid rule. And in general, the shape of the distribution of the data affects how much of the data is further away than 2 standard deviations, and we will talk about this more later in the course. Now, calculating the standard deviation. So let's go over a few things first. If x is a number, then the difference of x minus the mean is called the deviation. And in a data set, there are an equal number of deviations as there are items in the data set. And we use those deviations, that's what we're using to calculate the standard deviation. So if the numbers belong to a population, remember that we are going to use our population symbols. And if our numbers come from a sample, then we will use our sample symbols. Now in this course, we're going to use our calculators to calculate the standard deviation. However, you will need to be able to decide if we are going to be using a standard deviation for a population or a sample. If you would like, in our textbook, there is a detailed explanation of how to calculate the standard deviation by hand, but we will not be doing that in this course. We will be relying on our calculators. Now, this is just a comment. This is mentioned in your book, the sampling variability of a statistic. Okay, so a statistic of a sampling distribution was discussed in the measuring the center of the data section of your textbook, and it's how the statistic varies from one sample to another. Typically, we measure the sampling variability of a statistic by its standard error, and the standard error of the mean is a special type of standard deviation that we will cover when we get to the central limit theorem further in the course.